Okay, so here's what we're going to cover today. Databases and how developers deal with them. We're going to cover structured query language. What is it? How do you use it? A program called SQL Server that many of you have heard of or are already using. How you guys are going to use that. A program called MySQL, same thing. Another program called Sql Light. And then a technology from Microsoft called Link, L-I-N-Q, what that is and how you use it. And how to use a programming language in combination with SQL. So here we go. You ready? Okay, good, cool. All right, so big picture, like how do you deal with databases? So with certain rare exceptions, pretty much everything's accessed on the web nowadays. It's the key technology people use to use their programs to access data over the internet, that sort of thing, right? Many websites way back in the day didn't have to store any data. Those days are over. Virtually every single website out there in some way, shape, or form stores data. And even if you're not dealing with a web-based technology, there's going to be a source of data somewhere. Typically what data is used by business is what's called transactional data. If you're a sales company, what are the transactions, the sales transactions that occurred? If you're a manufacturing company, what are the transactions in terms of delivery of raw materials, creation of the actual pieces and parts, assembly to a final unit, shipping? Those are all transactions. There are other common uses of data or stores of data that will involve fixed things like all of your employees, right? Like all of your different plants you have all around the country or the world or whatever, right? You need to store data. It's got to be somewhere besides hopefully an Excel spreadsheet. So as developers, you interact with this stuff all the time. So we're going to deal with some fundamental concepts of how you would actually have most databases organized and then how you're going to interact with them. So I want to diagram out for you a traditional way that you would actually be able to grab a hold of or use a database. Several times I've gone over the concept of a server. And just to recap so you can see the parallels, if we're dealing with a web server, here's the paradigm. You've got Joe Bob Briggs out in Ohio, and he's got his PC, and on there is a browser. Let's say it's Internet Explorer because he's stuck in 2009. And he wants to see www.cactusfan.com because he really likes cacti. Okay, good, whatever. He issues a request to go to that page. That goes out to some actual machine. It's probably a PC of some sort. It's a computer, that's all we know. And who knows where it is? Let's say it's in the Ukraine because they found a way to make money off of it. So there's a machine in the Ukraine. Now, this is both hardware and software involved in this server. The hardware is just a central processing unit and some memory, just like the machines you guys are using right now, but it's been optimized for serving up web pages. This is ground we've all covered before, right? The software on top of it is what's actually technically known as the web server. And there's many different brands that are out there, but its job is to keep track of all the different files that are on there, and when you get a request for one, rapidly serve it up. So it goes back to the browser where the guy is in Ohio, and he sees the homepage of cactusfan.com. Everybody follow?
Yes.
Okay, good, cool. So now let's switch this around. And this isn't going to be a web server. It's going to be a database server. Not much changes. You're going to have hardware. They're going to be huge on memory because databases can occupy a tremendous amount of memory. They're going to have a set of software on top of the machine that actually can serve up data from the database over to whoever asked it. Make sense? This is a very simple view. We'll go into a little more detail later on, but that's how it works. Someone remote to the physical machine that's hosting the database issues a request for data from the database. That data is assembled and sent back. That's it. It serves up database results. It serves up results to what are called queries. A query is just asking the database for some set of information in the database. It could be anything. You could literally ask for, give me all of the data in the database. That would be a rather large set of results. You could get as particular as you wanted to. please give me every single sales transaction. There was this exact model of bicycle that happened between Tuesday at 1:15 in the afternoon and Tuesday at 1:30 in the afternoon, where the purchaser was a client that we've had in excess of 10 years. That's very precise. But you'll find that data in there somewhere. And that's what queries are, right? So the query goes from whoever is asking into this special software, down inside the database. The results come back and they get sent to whoever asked. Everybody follow? Good, cool. All right, so let's look at a specific, because it's the one you guys will use most often here in the school. This software that we most often use is called Microsoft SQL Server. Now, the reason I diagrammed all this out is because it can get a bit confusing. The server is also the hardware. It's a physical machine, but it's also the software. And so when you're talking about these things, you always need to clarify what's being spoken about. Are you talking about the software that sits on top of this thing and actually has the ability to go into the memory and pull out the data? Or are you talking about the physical machine itself? When you're dealing with database administrators, people that deal with actual physical hardware in whatever place you guys go to work, commonly those guys are talking about hardware. Something they can walk over and they built it themselves, or they had someone build it, and it's a massive machine with a huge central processing unit and lots of memory, but they're talking about physical hardware. And so they say there's something going on with the server. They mean the physical piece of equipment. It might very well be that the database administrator isn't involved in that stuff, and you're talking to him, and he says the server, and he means this piece of software that sits on top of it. And there's something about that that needs to be addressed. So always clarify what you're talking about, all right? Good. So this is not the only brand of software program out there that can do what we're talking about. We'll cover a few different versions of it as we go. But this is not the physical hardware, and it's not the database. The database is this collection of data kept in files down inside the memory of that computer. This is just the software that facilitates getting queries, pulling data out, and sending the results of the query back. You follow that? Okay. The terms are thrown around interchangeably, which is why I bring this up. Microsoft SQL Server is very often just called SQL Server. And you might say, hey, I need data from the database. And they might say, use SQL Server to get it. Or that database is in SQL Server. No, it's not in it. It's in memory down here. SQL Server is the software that lets you grab a hold of it, all right? Good. Okay, so now let's look at a few issues with this. So you have a database, and by the way, that is the most common abbreviation for database. Lowercase d, uppercase B. And a database could have a lot of things in it. It could have many tables, for example. And by the way, there are lots of different ways you can store data in databases. We're not going to get into all that in this particular lecture, okay? The one we're going to look at is what's called a relational database, where the data in one table relates in some way to the data in table 2, and that relationship is somehow defined. For example, if this is a customer table, somewhere in there you're going to store the ID of the customer. Over here is an orders table that records all orders of bicycles from the Acme Bicycle Company, and whoever ordered something, their customer ID got recorded somewhere. The fact that there's a relationship between this customer ID and this specific customer that's recorded up here is defined somewhere. That makes it a relational database. Good? Yes. Because you could just have one big giant pile of data and records everything. The customer, and then immediately after that, the first time they ever bought a bicycle, immediately after that, the second time they ever bought a bicycle, and all of it is just one big giant chunk of data in a text file. Not very easy to administer. So you want to strip, and again, we're not going to get deep into database design. You want to strip out common types of data and put them into their own tables, and then define the relationships between different tables. Good? Okay. So the database is going to have tables in it. And remember, the database is stored in a physical machine. There's the hardware. On top of that is the software, SQL Server in our instance for right now. Okay. There might be many databases that this SQL Server software is keeping track of. And some of them might be on other physical hardware. SQL Server is quite capable. So right now, let's just look at the fact that you have one piece of hardware and it has a single database on it. Well, you could have 5 different people all at once simultaneously sending in queries, these structured query language queries, into this SQL Server software, and it's got to try to be able to get data out of the database or manipulate the database in some way while protecting the data at all costs. The validity of the data is paramount. Very often, this stuff represents the entire heart and soul of the business. If you mess it up, you're toast. You're toast. You want to lose a job real quick? Mess this up. Okay? Good. So now you're looking at like the actual reason you have this complicated software. Its job, among many others, is to manage concurrent operations against the database. That's 2 or more people trying to do something on the database at the same time. And again, you can go way down the rabbit hole on exactly how all that works. And as you guys spend time on the job and become mid-level developers and senior level developers, you'll get a lot more data on exactly how that works. We can discuss the fundamentals of it. I think you guys can see the problem though is if you have, for example, 2 people trying to edit an order for the same customer at the exact same time, you got an issue. You see it? How do you manage that process? How do you make sure that they don't lock up and neither one of them gets entered? Or which order they come in, and how do you have to manage that stuff? The software handles that, okay? Good. All right. So let's discuss another aspect of how you deal with this as a developer. This one's kind of fun. So you guys all have your laptops for the school. And when you go to your job, you're going to have usually a laptop, frankly. Sometimes it's a desktop. Either way, you guys have to be able to do development work that very often involves the fact that you're accessing a database. There's that symbol for database, right? And you have your PC, your own laptop, and you're meant to design this database and the tables in it, or maybe it already exists and you're going to make some changes. Either way, here's this database, and here's your PC. And most of the time you put them on the same machine. You have your, if you're smart, your Apple machine that you put Windows on. Keep your comments to yourself. But we're just going to call it a PC for now, okay? But you have your PC, and you have the part that you're using. This is your Windows machine. This is where all of your documents and everything, this is where your Visual Studio that you use to do your development work is. And when you install this SQL Server on it, on your machine, it segments off a whole section of your computer, and it's no longer your computer. We're pretending that it's a completely different physical machine that might as well be over in the Ukraine. So you literally have to access it the same way that you would if it were 1,000 miles away, even though it's physically on your machine. It's a really important distinction, and one that's difficult to grasp sometimes, because very often for a developer, the first time they're learning to use SQL Server, they don't have a real life instance of it. What they have is a pretend one where you've done this, where you've done this. And most of the time when you're developing, that's what you'll do. So we do that. Now later on, as you move into more advanced projects, you'll have a situation where you have a SQL Server database that's a completely physical machine, a different physical machine. And you'll learn how to do that. But as you start to learn to use this program and others, remember this, that part of your machine is no longer yours. Okay. Questions about this? Anything? Good, awesome. All right, now let's go on to another aspect of this, okay? I'm going to cover 2 or 3 other variations on the software, the SQL Server software, okay? And again, this is just one brand of it. And it comes from Microsoft, and you pay a pretty penny for it if you're going to use it in the enterprise environment. It's an expensive software. It's also really valuable. It's very well maintained. It's robust. It's pretty awesome. However, there is another one that you guys have probably heard of, maybe not, called MySQL. How many people have heard of MySQL? Okay, good. MySQL. It has a nice advantage that it's free. It's open source. That means you can get a hold of the actual source code and tweak it and do cool stuff with it. You can't do that with Microsoft's product. You could, but they'd be kind of unhappy with you, okay? MySQL is part of an open source collection of software that I want to detail here right now. I've covered it in other lectures, but it's really important. People talk about a thing called a stack. This is a development stack. The most common one that you hear of in the open source world is called the LAMP stack. What this is Linux, Apache, MySQL, and PHP. What's that? Well, Linux is the operating system. It's installed on the physical machine. Apache is the web server software. MySQL is the SQL server, you like that? Software. That's not the Microsoft brand. It's just a software that helps serve up responses to SQL requests or queries. And PHP is the programming language. What this is a stack of software used for web development. WordPress, that almost everyone here has done, uses this stack. The physical machine has Linux installed on it, not Windows. The web server that's serving up those requests when people go to your WordPress site is an Apache. That's the name of the software, web server. MySQL is the database on the back end that's storing your pages. Because WordPress is kind of interesting in that it doesn't store those pages as HTML files, it stores them as data inside a database. And finally, PHP is a programming language that the actual pages are written in, and you can add rich, cool, awesome functionality to. You learn about that on our PHP course. So, great, that's awesome. What's the main stack that we teach besides that? Windows as the operating system, Internet Information Services as the web server software, SQL Server as the SQL Server, yeah, okay, and then C# or JavaScript or a few others as the language that you're writing in. Cool? That's another stack. All it really means is a collection of things that, taken as a whole, provide a nice framework for you to do web development. Good? Yeah. Okay. So let's look at this one, this MySQL. It operates in very much the same way as SQL Server, in that you have your hardware, which has an operating system on it. SQL Server software gets installed over that operating system. Some guy in Ohio, his PC issues a query. The MySQL software grabs that query. It goes into the database. It gets a result back. This is result set. And that result set goes back to the guy's PC in Ohio, and it gets displayed or used. Good? Awesome. Okay, good. So now, there's another one that's kind of unique. And when I say another one, I mean software used to administer databases. It's called Sql Light, Sql Light. It's very, very unique. Some of you have done the Python course, you use this, and you may have noticed that you were able to do it very easily with 1 or 2 lines of code written in your program. How is that possible? All these other things have, you install this software on a server, and then you have to get the right protocol, and your computer has to request data from it and get data back. This is different. SQL Light is serverless. When you need a SQL Light database, it gets spun up on your physical machine, in the memory of your physical machine, on the fly. and they find a place in the file structure to store that data. Love my handwriting, isn't that good? Good, so it's serverless, which means you don't have to get some other separate hardware and then a separate software on top of it and then send requests to that. That's all managed for you. What Sql Light actually is a software library. That's all it is. It's a set of pre-made software. And it's relatively small, and it works really efficiently. And you just ask it to create a database, and it takes care of everything else for you. The other thing about it is that it is a transactional database system. Now, so are the others. Explain what transactional means. And this is fun. So remember I brought up the idea that you can have a database and you got 5 different people trying to do something in the database at the same time? Each time you're trying to do something with the database, it's called a transaction. Now, you can do a lot of different things. Let's say you have a database over here and it's got 3 different tables. Table 1, Table 2, Table 3. You could have a very simple query where you're basically saying, can you get me out of Table 1 your top 5 customers by age? In other words, who are the people we've had as customers the longest time? Be kind of neat. You want to send them a special gift. Pretty simple. You're just going to hit this one table where it shows customers. You're going to look for when they became a customer, and you're going to filter by that, and you're going to get these 5 results back. Pretty simple. That whole process of the request, gathering the data, sending it back is a transaction. But it's a very simple transaction. You can get a lot more complicated. Let's say you want to do the following in order. The first thing you want to do is you want to find top 5 oldest customers that are outside of America. The second thing you want to do is register a credit to their account. If their account is not negative already, you don't want anybody who owes you money to get this special promotion. Now you get a little more complicated. You have to do things in successive order, right? The entire thing you're trying to do is one transaction. So what do you do if you get these 5 oldest customers selected and you start to go through and one of them actually has a negative? Okay, you don't update it. Now only 4 get updated. What do you do if at the exact same time that you're trying to change one of the, to get this process done, someone else over here in accounting department goes in and makes a negative balance happen on one of the customers that it happens you're trying to use because of one of the 5 oldest customers. And those 2 things come in virtually at the same time. Now you got a problem, don't you? Okay. Now, for the exact rules on how that would be evaluated and whether or not they're actually going to allow the transaction, there's a lot of detailed, geeky stuff about that. It's way beyond what we're trying to talk about here. The important thing is you recognize there could be a problem, right? And it might very well be that this registering a credit to their account, if their account is not negative, that may have, quote unquote, already happened by the time their account goes negative because of a different operation. What do? You don't want to give them the credit. They don't qualify for it anymore. So what you have to do is when you're trying to run this whole thing, don't make it official until you get to the end. Until it's met every single requirement and everything's fine. This transaction and every single action involved in it isn't actually executed against the database. The data doesn't actually change until it reaches the end and it meets all the qualifications. Until that time, everything that would happen is recorded in memory and only applied to get to the end and everything's good. Pretty interesting concept, isn't it? And the SQL Server software that you guys use, Microsoft SQL Server, is capable of recording an incredible volume of changes that are proposed, is this okay, changes. It can record millions and millions of separate changes to the database or gathering data, none of which actually goes and occurs for real against the actual data until it gets to the end and everything's okay. That's called a transaction. And it can have hundreds or thousands or millions of different individual steps, and only when they're all get approved at the end do they actually change the data. If they don't, the entire thing can be reversed. It isn't even that it's reversed. It never happened. It just gets canceled. Really important concept. Everybody got that? Good. That's transactions. Now, this brings up the next logical step in this, which is, okay, that's all well and good. How do you do this? How do you actually execute all these queries and everything against the database? And so far, it's all just like theoretical and looks kind of cool, and that's awesome. What do you do? Well, let's go back. You have a database. Again, the universal symbol for database is that. Anybody know why?
It's a container.
Okay. It's a container. That's a good one. Okay. The reason why is because hard disks, which have a little hole in the middle, then a round one, right, would be stacked on top of each other. That's a really horrible drawing. There's a rod going through and a rod coming out the bottom end to achieve a very, very high degree of memory in a physical machine. And they're all close to each other so that physical access of one to the next is minimized because the reader that grabs data off of them wouldn't have to travel very far. That's actually the physical structure of many database hard disks. Make sense? So it looks like that. See that? It looks like that. So when you draw this, that's why it means database. It's because it reflects the actual physical form that those hard disks take. I thought that was kind of cool. Okay, good. So there you go. You got a database, okay? All right. Now, there's two different ways to get data in and out of that thing. First one is, remember that it's on a physical machine. Here's your hardware. And there's software on here, and we're going to call that, because again, it's the most common one, SQL Server. Well, I don't know if it's the most common. It's the one that's most common in this classroom. Okay, good. So, SQL Server has a tiny little sort of sub-program called the management console. And the management console is very, very similar to an integrated development environment that you've seen before, where generally off to the left, I hope that doesn't come off, generally off to the left, you have not file structure, but database structure, where you have database called, say, Acme, and then underneath it are all the different tables. And you have a database called Joe, Pro, Co, and under it are all of its tables. You follow? Okay. Here's a really important point. Really important point. The actual graphical representation of a database and the tables in order that are under it bears no relationship at all to where and how that data is physically stored. You don't know where the data is physically stored. All you know is there's a ton of hard disks somewhere inside there on that physical machine, and somewhere is stored all that data. SQL Server, the software, it keeps track of that for you. That is abstracted away, and you're given a graphical representation of how these tables all relate to each other and how they're all in the same database. They might be stored in 100,000 different individual spots on 12 different physical disks. You don't know. You don't care. Make sense? Good. So what you'll have off to the left is a graphical representation of the different databases you might have, all the tables that are in those databases, and there's several other elements that we're not going to get into a bunch of detail with right now. Again, it's just a graphical representation. It doesn't reflect the physical storage of that data on the machine, right? So that's one part of the management console. The other part is a big text editor. What are you going to write in here? You're going to write a language called Sql. Structured Query Language. Sql is one of those things that's really deceptive in that it's very easy to learn. It's very easy to learn because essentially the operations are create, read, update, and delete. It's really all you're doing to the data. Are you adding data to the database? Are you reading data from the database? Are you updating some data that's already in there? Or are you deleting some of the data? What else is there? Well, that language, SQL, can be very powerful, very complex, and there are people who make it their life's work to be experts in it. It's fun. I like it. You're going to learn enough here to be dangerous. I don't mean that. You're going to learn enough here to be able to actually work with the basic elements of databases and write code that gets you the data you need and accomplishes create, read, update, and delete. Good? You'll also, by the way, be able to figure out ways to make the code that you write reproducible and called into action anytime you want, so you don't have to write it out each time. It's fun stuff, okay? But the point is you have a text editor here in this management console where you write this SQL. And SQL syntax, for those who haven't seen it, is pretty straightforward. It's not the subject of this lesson, but just as an example, it can be as simple as a select statement. Select customer ID from customer table, where customer age greater than 5. Whatever. You got a table full of customer data, you know their age, you want every customer that's older than 5 years old. It's that simple, okay? So, the point is this though. We talked about different ways you can access this data in the database. The most direct way is to be working in this management console, writing this structured query language queries to create, read, update, or delete the data, right? Good. So, how do you do this as a developer, as a software developer? Now, if you have a program, we're going to write a program that's going to be a web application. And it's going to be an order app for Acme Bicycle Company. Right? You're going to have a user interface, you have a business logic layer, you have a data access layer, and it's going to connect to the database. Here's my database. The user interface will be a screen called order, and you put in whatever model you want and what color you want and your customer ID, and you press order. The business logic layer will get this collection of data given from the form, which is the model, the color, the customer ID, and it'll use a section of code called the data access layer to then insert that data into the database. Very simplistic explanation, okay? But the point is that this is not going to be written in SQL, in structured query language. This can be written in a lot of different things, like C#, JavaScript, PHP, Java, C++, ad infinitum or ad nauseum, depending on your point of view. The point is this, is that you can use code here to generate SQL code that's then executed against the database. And then the results come back into your program. You follow that? Good. So, let's go over here for a second and see how that could work. Good, 15 minutes. So let's look at that exact situation here, where you have over here a database, and let's say in it is the orders table. this table will have like a customer ID. It'll have a model ID, and it'll have a color. And it'll have a date. You want to know when the guy ordered it, right? Good. Probably a lot more complicated in a real business case, but you get the idea. So over here, we're going to use a little bit of C#. You don't need to know C#. If you haven't gotten to that point, it doesn't matter, because I'm not even going to write it in real C#. I'm going to write it in pseudocode. Everybody know that word? Pseudo. It means false, not real. Pseudocode. It's going to look like code, but it's not going to be really code. All right, so what do we do? Well, over here on this side, if we were using the SQL Server Management Studio, SSMS, the thing I was just talking about, what you'd really do is you'd write a command. It's an insert, sorry, it's a update command. No, you'd be inserting, it's a new one. You write insert into orders table, and you'd have in parentheses all the data you can insert. It would be, what is this, 9, 12, 14. Hey, we just dated that for the people watching the video, cool. And then you have customer ID is 207, because that was the customer who was over here ordering. And then you'd have model ID is the 83 Alpha. It's a real good bicycle, you should buy it. And then you'd have color would be red. Good. So all that data needs to get inserted into the orders table just to record the fact that an order occurred. Make sense? And you can do that from SQL Server Management Studio writing this SQL code. We're not going to do that. We're going to have our program do it. So from the order form, it's a web-based form, down through right here in this section called the data access layer, we're going to deal with some language, in this case C#. And something's got to turn it into SQL, which is then going to get executed. It'll look just like that. And you'll get back a success or failure code. Did it actually work? I'd like to know, okay? And that's going to be returned back through here so your program knows that it worked. Good, awesome, did that, okay? So how do you do that? How do you make this C# code make SQL? How do you do that? Well, the answer is you're software developers. You make a piece of software that does it. Thank God you don't have to do that, though, because that's been done many times before. You get to be the, take advantage. You be the beneficiaries of the fact that people have done that. And the way they do it is by writing a special piece of software called an object relational mapper. Sounds all complicated, it isn't. Remember how we said over here in the database, you've got all these tables, and they have relationships to each other? Right? Good, different tables. These are tables in a database. Over here in your code, you have little things called objects. Well, let's use the example. You would have an order object. That object would have certain properties. Well, it would have a property which is called date, and that would be equal to 9, 12, 14. It would have a property called customer ID. It would be equal to 207. You would have a property called model ID. That would be equal to 83 alpha. And would have a property called color. It would be equal to red. Everybody following so far? Now you can do that. You can represent this in a lot of different languages. We're talking pretty basic stuff. You've created something. It's an artificial thing managed in memory called an order, and it's got 4 different properties: date, customer ID, model ID, and color. Awesome. Right in between the database and your code is this object relational mapper software. And it says, oh, if I get a list of these properties that's related to a thing called an order, I'm going to map that. It's going to be connected conceptually, mapped, connected conceptually to my orders table. And more than that, the object has these properties, 4 of them. 1, 2, 3, 4. I'm going to map those to the different columns, 1, 2, 3, and 4, in my table. And I'm going to figure out how to manipulate that and create the right SQL code that does all that. You don't have to do it yourself. Kind of cool, huh? You don't have to do that. You don't have to. Microsoft and many other people who make languages do provide a pretty basic way to take this SQL right here and just create a string in whatever language you're using and make it equal to all of that. The string is equal to a big long thing that says, insert into orders table 912 14 207 83 alpha red. And then you can literally send that down and tell SQL Server, please execute this like it was SQL code, and it will. It's one way to do it. There are a lot of other more valuable and versatile ways to do it. And this is one of the most common ones. So just to step back, just like big picture, what you're dealing with is the fact that we have all this really awesome software to manage databases. And we have software we write programs in. And you need a way to be able to run those from here. There's a lot of different ways to do it. But the place in your code where that is usually coordinated is loosely called a data access layer. Very loosely. There's just some place in the program you're writing where you'll have code that takes care of mapping between the stuff in your code down into the objects in the tables in your database and coordinating create, read, update, and delete operations. Good?
Yes.
Okay, good, cool. All right, we've covered a lot. I think we've covered maybe even more. I can see a little bit of glazing of the eyes there, okay? This recording is for you. Grab it, watch it, pause it, go backwards, laugh at my jokes, laugh at my clothing, do whatever you want, I don't care. It's there for you. And if you want additional study, just grab it. There's a lot of data on this, all right? Good, thank you.